Okay, cool. That's great, guys. Let's just get to it. First things first. What's the subject of this week? The subject of this week is Mr. B's Workshop Part 2. Now, the focus we're going to be working on is understanding order of operations. What that means is it's generally referred to as BIDMAS. Brackets, exponents, division, multiply, addition, and subtraction. Now, for you guys today, most of it's around the order. You know, if you're in the chocolate mice, it's all about the order of just multiplication, division, addition, and subtraction. And right at the end, you get a couple of tricky ones with brackets. But we're keeping everything the same. Your apples cost the same amount, your bananas cost the same amount, your carrots cost the same amount, so your A, B's and C's and your X's are all worth the same thing. I didn't want to change any of that for you, so it's very similar to what you did last week, except the problems have ramped up a level, and we're talking about order of operations, so BIDMAS. So let's have a look at this. So that stands for the brackets, which that means that anything that's written inside a bracket goes first. So 2C plus 1, take away 5, equals. Now, I'm going to work through this with you later, but what that would say, what's that saying is you would do the part in the brackets before you would do the part outside the brackets. So you would go 2 times C, which we remember as C is worth 2. We should always have our little key up the top. C is worth 2. A is worth 3. And B is worth 5. It's worth 5. So that is essentially telling you that you would go 2 times. 2 is 4 plus 1. That's 5. Then you would take that answer and you would subtract 5 from it, which would leave you with an answer of 0, just by chance. So the B stands for brackets, and it means whatever's in the brackets, you do first. E stands for exponents. Now, for you guys, we're not going to look at exponents. Exponents are more level 4 plus, but I'll show you what they look like. Exponents look like the little number above another number. So, you know, you might have C to the power of 2, or C to the power of 5 even. You know, and you don't need to worry about that at the moment. We may get to it later on, but that's what that stands for. It's exponents. It's the little number up the top. Division is the D. So that means that in a problem that has division in it and also has addition or subtraction in it, you would do the division part before you would do the addition or the subtraction. Now, even though it's said to be BIDMAS, division and multiplication are worth the same amount. What I mean is, even though the D comes before the M, if a problem looked like 1 divided by 1, but before it had 5 times 1 divided by 1, you wouldn't necessarily go 1 divided by, let's go 1 divided by 2. You wouldn't necessarily go 1 divided by 2, do this part first, and then multiply it by 5. You would just go in the order that naturally left to right. And it's the same with addition and subtraction. Even though A comes before S in the BIDMAS, you wouldn't necessarily, if a problem came up where you had something like this, where you had 5 take away 3 plus 6, you wouldn't go, oh well, that addition is worth more, because it comes in earlier, so you wouldn't go 3 plus 6 is 9, 5 take away 9 is -4. That's not correct. That is not correct. You would just go from left to right, which would be 5 take away 3, which equals 2, plus 6, 2 plus 6 equals 8. That is correct. So that's the tricky thing. Those two there and these two here are actually equal, even though if you read the BEdMaths sort of thing, it would seem that the divided by and the divided by comes before the multiply. But in actual fact, they just come together. And it's the same with the add and subtract. So I've ranted on about that enough. I'm already at 5 minutes. Oh my goodness. So let's have a look at a couple of questions. And I'll tell you about the one other tricky thing. Okay. So what we're going to do is we're going to have a look at this problem here. 7 for the Albert Feinbergs. Okay, so we're going to rub all this stuff off. We're only going to look at 2 problems, and we'll show you this next part. So that's gone. And the problem is 2 minus 5a minus c. So we go, let's write problem in 2 minus 5a, was it? Yep. Minus c. Now, the order of operations tells us that division and multiplication comes before any subtraction or addition problems. So first thing we need to do is go 5 times a, 5 times 3, 15. 2, take away 15, take away 2. 2, take away 15, -13, take away 2 more, -15. Sure wish I'd chosen an easier problem for an example, because some of you guys would be getting confused about going into the negative there. Good one, Mr. B. But essentially, 0 is there. So when you have 2, 1, 2, and I want to go back 15, I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now I have to go back another 2. 1, 2. So I can just count that back. 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, -14, -15. That's how I got my answer to -15. When you get more used to working in negative numbers, you'll become better at that. I'm going to give you an easier one. Very similar. That was a shocking first example. Sorry, running into negative numbers. Kind of pushes it to the upper level 3s, guys. So if that didn't make sense to you, again, that's okay. I did choose something from the Feinberg side. I'll choose something from the here we go, from this side, the chocolate mice side. 44c minus 87. Well, that goes in normal order. Actually, let's not choose that one. That's a given. Here we go, 93 minus 7b plus 4. that'll give us a positive number. 93 minus 7b plus 4. Okay, so if my first thing is to do my 7b, which is 7 times 5. Now I know that in my head is 35. It's okay if you don't know it on the top of your head, you can draw your dots. One group of 5, two groups of 5, carry on, you'll get 7 groups of 5, which is 35. So then now I've done my multiplication, so I can go 93 take away 35. So take away 30 would be 63, take away 5 would be 58, plus 4, 58 plus 4. So I broke this, I used place value. I broke this into 30, took 30 off 93, which brought me down to 63, and then I took the 5 off 63, which brought me to 58, and then I simply added the 458 plus 4 is 62. Easy. Last thing to watch out for, if I haven't done it to this group at all, so Albert Feinbergs don't need to worry about it. I've done it over here to the, no, the chocolate mice don't have to worry about it. So chocolate mice, you don't have to worry about this next section, so I'm not going to actually talk about it. I'll talk about it later on in the video. The video is already too long. Okay, so we're going down to this. This section here is a series of puzzles. Now they can all be solved with an algebraic equation. For example, but what I'm asking you to do is write out how many blocks will be in the next image. So for example, this one here is number 1, right? And it's got 5 blocks. This one here has got 9 blocks, and it's number 2. And this one here has got 13 blocks. So you can see that the next one is going to have 4 more blocks. 4 more blocks than 13 is 17. So that's your first step, and that's fine. If you're just writing out how many your next blocks, how many the next shape would have is 17, that's fine. And I also want you to draw it. My last thing is a very tricky thing, and I only want the people in Albert Feinbergs to worry about it, and it's called trying to make it into and it's basically trying to make it into a formula. So let's have a look at those numbers for a second. Again, this is only Albert Feinbergs from here on out, guys, so if you're part of the chocolate mice, you don't need to worry about this, though you can watch it if you find everything easy. So Albert Feinbergs, if you have this pattern of number 1 is 5, so N1 is 5, N2, number 2 equals 9, number 3 equals 13, number 4 equals 17. Now the idea is to try and make an equation that can solve this problem. So what you have to do is you have to think about how you could make it work. So you use n for number, and you do trial and error. So I'm thinking this number is, this here is 5 times this one here. So what I'm going to do is I'm going to try n times 5. Will that formula work? So my second number is 2 times 5. It doesn't work because if the formula of n Oopsie, I just, my command's say that. If the formula of n times 5 worked, I've lost the ability to draw now. How intriguing. If the formula of n times 5 worked, I would have just starting again. So number 1 is 5. Number 2 is 9. Number 3 is 13. Number 4 is 17. Now, if the formula of n times 5, the number, and like, it's the third one down, worked, then my second answer would be 10. But my second answer isn't 10. It's 1 less than 10. So let's go to the second one, and we could run with this idea and see how we can get it to work with our second number. So it's n times 5 minus 1. So let's try that equation. So it works perfectly for that one. Does it work for this one? No, it doesn't. So we've got a problem, because if it works for this one because n is 2, so 2 times 5 equals 10 minus 1. It works for this one, but it doesn't work for this one because 1 times 5 is 5. And then I'd have to minus 1, which gives me an answer of 4, and the answer is 5. So you go through this process. It's just a problem-solving process. It's not easy. It's not supposed to be easy. The actual formula for this one, if you look at this, is 1 is 1 less than the number. And that's where your hint is, because minus n minus 1. 5n, so 5 times the number, 5 times 2, minus the number, minus 1. 2 minus 1 is 1. So that gives you 10 minus 1, which is 9. And it also works for this one because 5n, 5 times 1 is 5, minus the number 1, in this case it's 1, minus 1, which is 0. So 5 minus 0 is still 5. And then it continues to work. For number 3, 3 times 5 is 15, minus number 3, take away 1, which is 2. So 15 minus 2 is 13. And this equation can help you solve it at so if we're at the 10th different step, and you could draw it out, but if n equaled 10, 10 times 5 is 50. Take away n minus 1, which is 9. Oh, sorry about that drawing. So 50 minus 9 would be 41. On the 10th step, there would be 41 blocks. Tick. So that's what the useful nature of that is. I know this has been a long video. You don't have to watch it all. Give it a go though.